insert the elements, that is the entry of the elements take place. But what does the entry of the elements takes place? The entry of the element takes place at the rear end, right? And deletion is going to happen from the front end. Alright, that is the basic idea we saw. So initially, let's consider this Q, alright, that is basically empty, that we created using this function called create Q. So initially, the front is going to be 0. So this is my front. Front is going to be 0. Alright, and rear is going to be capacity minus 1. So this is going to be my rear end. Fine. And Q of size. So initially, there is 0 elements. So 0. Q of array is also created of size, capacity being 6. So we have this as well. So return this Q. So we have this Q right here. So what am I supposed to do? Let's have some insertion operation. Okay. So the elements I want to insert is this 6, 18, 2, 5 and 4. Alright. 3. Alright. So now let's just look at it. Okay. So you initially have 1, 2, 3, 4, 5, 6. But it can only hold it can hold 6 elements. Okay. 1 as well. So after I insert everything, so initially 6 is going to come and I insert 6. Alright. So then what will happen? Then rear end is going to be right here. Okay. Fine. And then 18 comes in. So when I insert 18, front is going to remain the same, but only the rear pointer will go back here. Alright, so rear will always point to the last most element that is present in the queue. And then 18 is inserted, so then comes 2. So I try to insert 2 right now. So what will happen? The rear pointer will again increment, and this is going to be my rear pointer. If you notice, right, what is also happening? The size is also getting incremented. So right now, what is the size? The size is initially 0, right? So right now, what is the size? The size is 3. So how many more elements can I insert? I can insert 3 more elements, right? So then I insert 5. So the rear end will point to this. Alright? And then 4, rear end the size will also increment to 4. And when I have to insert this 4, what is happening? First of all, the rear end is incremented and rear will start pointing right here. Alright? And the size will get incremented. Alright? That's it. These are the only 2 operations that are taking place. First of all, the rear end is incremented. Secondly, the size is incremented. Thirdly, I insert the element in the array that I have. Alright? So then 3. So the rear end will get incremented, the size will get incremented, alright, and then I insert the element. Fine. So initially the rear end gets incremented, the size gets incremented, and then I insert the element. Now I have this element 1. Will I be able to insert it? Obviously no, because the capacity is only 6, and all the 6 elements are right now filled, right? So I cannot insert the element 1. This is called as overflow condition. Okay, so why am I telling you that it's called as overflow condition? Because you can no longer insert the element into the queue. So why did I tell that you can no longer insert the element? Because the capacity is reached. How did I know the capacity is reached? Because the size is equal to the capacity, right? Size is the number of elements that is present in the queue at that particular point of time. And the capacity is the maximum amount of elements that the queue can actually hold. So when the size becomes equivalent to the capacity, you can no longer insert any more elements into the queue, right? So that is called as the overflow condition. That is going to be our end point. Alright, so let's write a function for this. So NQ operation. Should it return something? No, not necessarily. Why? It's not going to return anything. Alright, so what should I get from the user so that I can insert? I'll have to get the queue so that I can make changes to the original queue, right? So queue star queue. Fine. So next queue. Okay. So initially, what should I check? I should check whether I will be able to insert the elements or not, or is it already in an overflow condition. So if Q of capacity and Q of size are equivalent, then which means it's an overflow condition and I cannot insert any more elements, right? So if Q of capacity is equal to Q of what? My size. Then don't do anything. Simply return because you can't insert it. This is overflow condition. Else, what should I do? Else, I'll be able to insert the elements. So, else part. What did we do initially? We'll have to increment the size. First of all, is increment the size. First of all, increment the real value. Q of real is equal to what? Q of real plus 1. Alright, Q of real plus 1 mod of Q of capacity. Why am I doing this? Why modulus of Q of capacity? Because initially, right, during initialization of the Q, what did you give to be as a real value? We gave it to be as capacity minus 1. Alright, so initial value for our instance, if capacity is 6, initially real is going to be pointing at 5. Right? So initially real was pointing at 5. It was pointing right here. Okay. But after the first element's insertion, right, for instance 6 here, what happened? Q of real is equal to Q of real plus 1. So real's value was 5 initially. So 5 plus 1 will be what? 6. 6 mod of 6 will be 0. So therefore real was pointing right here after the insertion of our first element 6. And then during the second iteration what will happen? During the second iteration real's value is right now 0. So 0 plus 1, 1. Modulus of Q of capacity is going to be Q of capacity 6. So 1 mod 6. So after the insertion what will happen? Real will have a value of 1. So this is how things will change, right? So that's why we have Q of capacity because we initially had the value of capacity minus 1 for the real, right? And then, so Q of real is this. Secondly, we will increment the size. Q of size is equal to Q of size plus 1, alright? And then, what is the third thing we have to do? We'll have to insert the element, right? So Q of array. Where should I insert the element? I should insert the element at the real location. Alright, Q of array of Q of real must be equal to what? The element. So along with this, I have to get the item as well that I have to insert. Right? It's equal to. So this marks the NQ operation. This marks the end of the NQ operation. Right? I hope you understood it. So now let's look at the DQ operation. Alright? During the DQ operation, right, what will happen? The elements will get deleted from the frontmost position, right? Because the first element inserted will be the first element to be deleted. So 6 will get deleted first, and then 18, and then 2, so on, right? So what will happen is that first of all, when I perform the DQ operation, what should happen? 6 will get deleted. Alright? So firstly the element gets deleted, and then the front will start to point to the element 18. Right? So the size right now will get decremented. So there are three things happening. The element is getting deleted. Alright, and then the front position is getting incremented, and then the size is getting decremented. Alright, so these are three things that get carried forward. So after this, what will happen? 18 will get deleted. So the front position will right now point here. Alright, and then the size will again get decremented. Alright, so these are three things. So as I carry things forward, then 2 will get deleted, then 5, then 4, then 3. Ultimately, what will happen? Front will be here. Okay, 5, and then the size will be 0. Right? When I cancel out 3, what will happen? The size will ultimately be 0. And then later, when I try to perform the DQ operation, right, I will not be able to perform the DQ operation because why? Because my entire queue is going to be empty, right? There is no element present in the queue. So what can I delete? I cannot delete basically any element, right? So this is called as the underflow condition. When I have no elements that's going to be present in my queue, I cannot delete anything basically, right? So that is called as the underflow condition. Alright, so what should our function basically written? It's not written anything. void. Alright, it's called as a dequeue operation, dequeue of. So what should I get as input from the user? I'll have to get the initial queue, right? Okay, so first of all we have to check while performing the dequeue operation, is it having the underflow condition? We have to check that first. So if queue of size is equal to 0, which typically means it's having an underflow condition, then what should I do? I have to simply return. I have no operation to basically perform. Else, I'll have to delete the element that's present in the front. Alright. So queue of front, I'll have to delete that element. Alright. So before deleting that element, let me store the element that's present here. So how will I store? Queue of array, okay, of queue of friend is going to give me the element that is going to be present at the front. This statement is going to give me the element that is present here, right? And then what should I do? Queue of front must get incremented is equal to queue of front plus 1. Later what should happen? The size must get decremented. So queue of size is equal to queue of size minus 1. Alright. Lastly, I'll have to print that Cout which item got deleted. This item got deleted, right? So that item is getting printed. Fine? Yes. So this was the end of our dequeue operation. So initially what you do? You check for the underflow condition and then you capture the element that is present at the front to most location of the array, and then what you do? You increment the front operator, alright, and then you decrement the size. Lastly, you just print the element that was deleted. Fine. So this is how you carry out the entire operation using arrays. Alright, so let's look at the linked list implementation of the queues. Alright.